Sixth grade, this is 5.4 classwork number 7. You have 38.24 divided by 0.15. Now remember, when dividing decimals, you must have a whole number outside the division bracket. You cannot have a decimal outside the division bracket. And so if you do, you have to move the decimal to get it to be a whole number. Now, to get 0.15 to be a whole number, I have to move this decimal 2 places to the right. Now remember, however you move the decimal here, you must also move the decimal on this number the same exact way. So I got to go 2 places right, 1, 2, and my new decimal would be right there. Okay, now let's rewrite the problem. Inside the division bracket, we now have 3824. So 3824. That's my number inside. My number outside is no longer 0.15. It is now 15. Okay, so this is my new problem since I moved the decimal. From this point, it's just long division. I follow the same exact steps as long division. How many times can 15 go into 3? Well, it can't. It's too big. But what about how many times can 15 go into 38? Twice. 2 times 15 is 30. I subtract and get 8. Bring down the next digit, which is 2. How many times can 15 go into 82? 5 times. 5 times 15 is 75. Subtract and get 7. Bring down my next digit. My next digit is 4. How many times can 15 go into 74? 4 times. 4 times 15 is 60. Subtract and get 14. So I'm not done dividing yet because I don't have a remainder of 0 yet. So what's my next digit that I'm going to bring down? I don't have any more digits. What do? Well, here I have to add a 0 after the decimal. Well, where is the decimal? I don't see it. Well, if you don't see it, it's after the last digit that you do see. It's right there after the 4. And after that decimal, there are placeholder zeros. I can add placeholder zeros. Okay, now remember, in your quotient, your answer up here, the decimal point goes straight up. So it's right after that 4 in my quotient. Okay, now that I've added a 0, I can bring it down. So now my number down here is 140. How many times can 15 go into 140? Well, it can go in 9 times. 9 would be the first digit after the decimal. 9 times 15, that's 135. I subtract and get 5. I'm not done dividing yet, right? Because my remainder is not 0 yet. So I have to add another placeholder 0 so that I can bring it down and continue dividing. How many times can 15 go into 50? Well, it goes in 3 times. 3 times 15, that's 45. Subtract and get a remainder of 5. My remainder is not 0 yet, so I'm not done dividing. So what do I got to do? Add a placeholder 0 so that I can bring it down. My number is 50. How many times can 15 go into 50? Well, it goes in 3 times. 3 times 15, that's 45. Subtract and get a remainder of 5. My remainder is not 0 yet, so I got to keep going. I got to bring down the next digit. So I have to add another placeholder 0 and so that I can continue dividing. Do you guys see a pattern here? I'm going to continue to get 50 every single time, no matter how many times I do this, and 15 goes into 50 3 times. So basically, we're going to continue to get 3 forever and ever and ever. We'll have 3s continuously. Okay, well, this decimal will never end. And so when the decimal never ends like this, we call this a repeating. This is a repeating decimal. Okay, terminating decimals, they end. They do have a stopping point. Repeating decimals do not have a stopping point. They continue on forever and ever and ever. And so how are we going to write this number? How are we going to write this? Well, if a digit repeats, we use what's called a repeating bar over the digit that repeats. And so my answer is going to be 254.93, but this 3, only this 3 repeats, and so I put a repeating bar that looks like that over the digit that repeats. So it's 254.93 repeating. That would be my final answer for number 7.